Yo, yo, Math by the Moon here with some information for you today on operations with complex numbers. So we're going to be adding and subtracting, specifically maybe a little bit of distribution, and let's get after it. So one of the most important things that you're going to see that's going to happen multiple times over and over again is, remember, I is an atheist. He does not believe in higher powers. So if I doesn't believe in higher powers, you have to simplify them anytime you come across that. And the one that happens the most in these types of problems is I squared. And you better look it up. You better know what I squared equals. It'll be haunting you in your sleep. It'll be like I squared equals -1, -1. And hopefully you won't forget. Okay, so we're going to get after some of these problems. So you might want to pause it and jot this stuff down. But the standard form of a complex number is a plus bi. And what that stands for is a being the real part, the number, without a letter, without anything after it. It's just the real part. And the b being the coefficient of the imaginary piece. So I always want you to get in the habit of writing the real number first and then the imaginary part second. Okay, the rest of the rules are really simple. It's just do what you normally would have done in Algebra 1. Combine like terms. Take care of any distribution that needs to happen. Okay, meaning anything in front of a set of parentheses that's multiplying an entire quantity. Do it. The trickiest part you're going to see happens in question number 3 down below. And kids mess up subtraction. They just do. So you have to be exposed to it again. Number 1's no surprise, okay? Number 1 should be 13 plus 3i. And if you're stuck on that, I think we got more problems than we know what to do with. Basically, you just combine like terms. 8 and 5 make 13. This is -1 plus 4 makes positive 3i, okay? That's as far as it goes because you can't put the 13, add it to the 3 because they're not like terms anymore. 13's real, 3's imaginary, 3i. Question number 2, kids mess this up because they forget that this subtraction means they're subtracting the entire quantity. So they have to subtract 3, but then they have to subtract the -6. Subtracting a negative turns into +6. So that's where the mistake will happen. So it's 7 minus 3, which is 4, and 6 minus -6 is really plus, would be 12i, okay? And you know what, it might not be a bad idea if you distribute and write down an entire line. So maybe your math notebook would have this: 7 plus 6i minus 3 plus 6i. And all that we did is we dropped the parentheses out of the problem because they're no longer significant. There's nothing to the left of this set of parentheses. So it's not even doing us any favors. It might as well not even be there. So I got rid of the parentheses. This one over here, before I can get rid of the parentheses, I have to take this -1 and distribute it through. Okay? So I do that and I end up with this. And when I get rid of the parentheses, now I can associate in any way I would like to, combining like terms. So associate the 7 with the -3, make it 4, and the 6 plus the 6 make it 12i. By all means, if you can do it without having to write this extra line here in the middle, go for it. But there's going to come a point when the questions get longer and longer that you're going to want to write it out line by line. Plus, I can find out where you might have made a mistake. All right. Number 3, the last thing here to do. Kids are going to do some silly stuff. Let me get this out of the way. Hide. Loading video camera. I don't know why people are blowing me up. So a lot of kids are going to take this 10 and they're going to think they have to distribute or multiply with it. But in reality, I'm just going to drop it down at first. I am going to distribute this -1. So it would really be -6 and a -7i. And now my parentheses are no longer, I'm not locked up anymore, okay? So plus the 4i drops down. So then I can combine the like terms and get 4 minus 3i, and that's where it's done. So here's your 3 examples, all right? Again, the most concerning beef is to distribute the subtraction sign. All right, that's definitely the most important part. So I'm not sure what's going on with my Zoom, but we're going to go to the next slide here, and I want you to try. I want you to pause the video, and I want you to try. I'm going to tell you something over here on number 3. You might get something like I squared, okay? Remember that I squared equals -1. You have to remember that, okay? You must remember that. So, am I still in this Zoom? I think I am. So let me just do this. You pause the video. There we go. There it is. All right. I like to see my face when I'm talking to you. All right, pause it, see if you can get it. There they are. There are the wonderful answers. Okay, again, over here, you distribute this -i. It's a -i. So when it comes over here, it's a -14i squared. Check this out. I squared is equal to -1. So if I were to substitute that in there, it would really end up +14. It would really end up a +14. So what wasn't real became real. Yeah. So I squared became a real number again. I combined my common variables with I here and got that. And finally simplified the 43 plus the 14. Over here, distribute the -1. Any subtraction needs to be distributed, and then I can combine the like terms, okay? And if you got some of this wrong, maybe it's just your silly sign mistake. Always take the sign to the left of the number with it. So that's not just 13, that's -13. That's not just 4, that's -4. All right, next slide. I would like you to try and step your game up and see what you can come up with these. Remember, I squared equals -1. Pause it. Pause it. See if you can get them. There they are. There are the correct solutions to the problems with adding and subtracting. Again, watch out for distribution. Make sure you take care of it. Distribute subtraction signs. that's very important. We'll do plenty more practice in class, and you'll get far and away really good at this. So let me know if you have any questions later.